Hello everyone, welcome to course study on solid mechanics. In today's lecture we are going to discuss a new topic of unit number 6 and the title of it is eccentrically loaded column, and we are going to consider a uniaxial condition for the same. Okay, so first of all we will discuss the concept of direct load, and after that we will discuss the concept of eccentricity. Okay, so what does it mean direct load? It is nothing but it is the load whose line of action coincide with the centroidal axis of the column. Therefore, it is called as a direct load. It produces the direct stresses only. So as per the given statement, direct load is nothing but it is a load whose line of action it coincide with the centroidal axis of the column. Therefore, it is known as a direct load, and the stresses induced due to it are the direct stresses. Okay, so from this figure we have a column whose one end is fixed one, whereas other end is subjected to an axial load P. Okay, and that particular load, the line of action of this particular load coincides with the centroidal axis of the column. Okay, therefore this particular axial load P is coinciding with the centroidal axis of the column. Therefore it is known as a direct load. Okay, and due to this load the stresses induced are the direct stresses. Okay, therefore from figure we have P is equal to axial compressive load that we have already discussed. A is nothing but it is the cross section of the column, area of cross section of the column. So that particular cross section, it may be a rectangular section, it may be a square section or a circular cross section. Depending upon that we are going to consider the area. Once you know the value of force and area, we can easily find out the value of direct compressive stress due to the axial load. Okay, therefore it is given by sigma d is equal to P by A. It is given by sigma d is equal to P by A, and after putting the value of P and A, after putting the unit of P and A, we will get the unit of direct compressive stress, which is equal to Newton per mm square or megapascal. Okay, so this is all about the concept of direct load. So remember that due to the direct load the stresses induced are the compressive stresses only. Okay, direct stresses are developed due to the direct load, and it can be given by P by A. Now we are going to consider the concept of eccentric load, and after that we will consider the definition of eccentricity. What does it mean? So what is eccentric load? The load whose line of action does not coincide with the centroidal axis of the column, then it is called as a eccentric load, and due to the eccentric load it produces the buckling into the column. Remember that eccentric load produces the buckling into the column, and due to that the stresses induced are both that is direct stresses as well as the bending stresses. Okay, so as per the given statement, eccentric load is nothing but it is a load whose line of action does not coincide with the centroidal axis of the column. Okay, so from this particular figure again we have a column which is fixed at bottom, and other end is free one, and it is subjected to a load P. Okay, and this particular dotted line, it is the centroidal axis of the column. Okay, so from this figure we can observe that the line of action of this particular P, the line of action of this particular P is not coinciding with the centroidal axis of the column. Okay, therefore it is known as a eccentric load. Okay, and due to that particular eccentric load the buckling of the column takes place. Remember that due to the eccentricity only the buckling of the column takes place. Okay, and due to that buckling the stresses induced are the direct stresses as well as the bending stresses. So the resultant value will be the direct stress plus the bending stress. Okay, so this is all about the concept of eccentric load. Now we will discuss eccentricity. Eccentricity is nothing but it is the distance between the axis of the column and the line of action of the load. Okay, therefore from figure E will be termed as a eccentricity. Okay, so eccentricity is nothing but it is the distance between the axis of the column and the line of action of the force or the line of action of the load is nothing but the eccentricity. Okay, so from this figure, E is nothing but is the eccentricity. From this figure, E is the eccentricity, and this is the cross section of the column. This is the cross section of the column A, B, C, D. We have the axis XX and YY. Okay, and this B is nothing but it is the width of the column, and D small d is nothing but it is the depth of the column. Okay, from this figure you can see that we have one point E. Okay, we have the value of E. Okay, and it is nothing but it is the eccentricity about YY axis, because about YY axis we are measuring the eccentricity. Okay, so from this figure you can see that whatever the load we are going to apply, it is an eccentricity of E with respect to YY axis. Okay, so this is a case of uniaxial stress. It is a case of uniaxial stress. Okay, after that we are going to discuss the biaxial stress also. Okay, so first of all we will discuss the uniaxial stress. The expression for the bending stress can be given by, now as we know that due to the eccentric load, the stresses induced are the direct stresses, which is given by P by A, and the bending stresses, which we have to calculate it from the flexural formula. Okay, therefore we will consider the expression of bending stress. So from flexural formula we have M upon I, which is equal to sigma by Y. M upon I, which is equal to sigma by Y. So in this case we are denoting it by the letter sigma B. So it we will consider it as a bending stress. Sigma B is nothing but it is the bending stress, so which is equal to M upon I into Y. Okay, where I is nothing but it is the moment of inertia of the column cross section about the axis YY, about the axis YY, because our load is eccentric about YY axis. Our load is eccentric about YY axis. Therefore, we are going to consider the value of I equal to IYY, and it is nothing but it is dB cube by 12. Okay, now M is nothing but it is the moment formed by the load P. M is nothing but it is the moment formed by the load P. Okay, therefore for a given load P, we have a perpendicular distance about the centroidal axis E. Okay, therefore the value of moment will become P into E. The value of moment will become P into E. Okay, where P is nothing but it is the load applied with an eccentricity E. Okay, that we have already known. Y is nothing but it is the distance of the point from the neutral axis where the bending stress is to be determined. Okay, Y is nothing but it is the distance of the point from the neutral axis where bending stress is to be determined. Okay, so we will consider the extreme fiber for this particular case. Okay, so in this manner the expression for the bending stress can be calculated by using the flexural formula. Okay, now we will come to the formula for the maximum stress and minimum stress. Okay, therefore column with eccentric loading we will consider, uniaxial state we will consider. Okay, so from figure, P is nothing but it is a load with an eccentricity E with respect to YY axis. Okay, B is nothing but it is the width of the column cross section, and D is nothing but it is the depth of the column cross section. So you concentrate on this particular figure. From this figure we can easily see that P is nothing but it is the value of load with an eccentricity of E with respect to YY axis. This particular B is nothing but it is the width, and D is nothing but it is the depth of the column cross section. Okay, so as discussed earlier, all of you know that eccentric load causes both direct stresses as well as the bending stresses. Therefore the total stress is given by, therefore the total stress or the combined stress can be given by combined or resultant stress is equal to direct stress plus minus bending stress, plus minus bending stress. Therefore sigma is nothing but it is the value of total stress, which is equal to sigma d plus minus sigma b. Sigma d is nothing but it is the value of direct stress, and sigma b is nothing but it is the value of bending stress. Okay, so all of you know that direct stress can be given by p by a. After that, the bending stress can be given by m upon I into y. Okay, therefore we will have the final value of resultant stress sigma is equal to p by a plus minus m upon I into y. Okay, now depending upon the maximum stress value, we will consider the positive sign. For the maximum stress value, we will consider the positive sign, and for the minimum stress value, we will consider the negative sign. Okay, therefore the maximum stress sigma maximum can be given by p upon a plus m upon I into y. P upon a plus m upon I into y. Therefore, after putting the value of area, after putting the value of moment and moment of inertia and y value, we will have p upon a plus pe. The value of moment will become pe divided by db cube by 12, because it is I y y. Our load is eccentric about y y axis, therefore it will become db cube by 12 into b by 2 into b by 2. Okay, after solving this equation, we have the final answer p by a plus 6pe divided by db square. After solving this particular equation, we will have the final answer for the maximum stress p by a plus 6pe upon db square. Okay, this is the value of maximum stress. In the same way, we will have the value of minimum stress also. Again, we will consider the same formula, only the sign will change. Okay, and that will be the negative sign. Okay, therefore the minimum stress will become p by a minus 6pe upon db square. Okay, it will become db square. Therefore this is the value of minimum stress. Okay, a note is given regarding it. Consider compressive stress as a positive and tensile stress as a negative. Therefore, from resultant stress diagram, we can say that the stress will be maximum along the layer BC and will be minimum along the layer AD. Okay, so we have to consider the sign convention. Compressive stress, we have to consider it as a positive, whereas tensile stress, we have to consider it as a negative. From the resultant stress diagram, this is the resultant stress diagram. This is the resultant stress diagram. We have the maximum value along BC. Okay, we have the minimum value along AD. Okay, so the value, the diagram will be in this manner. Okay, therefore from resultant stress diagram we can see that the stress will be maximum along layer BC. Along this layer BC, the stress will be maximum because we have the load eccentric about y axis and it is acting along BC side. It is acting along BC side. Therefore that particular side will be under extreme stresses. Okay, and this particular fiber, this AD, will be under minimum stress condition. Okay, therefore if sigma minimum equal to 0, then it means that no stress is developed along AD. If the value of sigma minimum is 0, then it shows that no stress is developed along AD, because sigma maximum will be along BC, sigma maximum along BC, and sigma minimum will be along AD. But if you have the value of sigma minimum equal to 0, then it shows that no stress is developed along AD. Okay, if we have sigma minimum equal to negative, that is if we get negative sign, that indicate that a tensile stress is developed along AD. So this particular extreme fiber, will be under tensile stresses. Okay, after that, if we have sigma minimum equal to positive, then the stresses developed are compressive in nature. Okay, so this is all about the concept of column with the eccentric load. Okay, and in that case we have considered the uniaxial state. Okay, in the next lecture we will consider the column with eccentric load, and in that case we will consider the biaxial condition of the column. Okay, so we will stop here. Thank you.